Hi everyone. Today we'll be discussing the LeetCode problem of the day. Calculate money in LeetCode Bank. So here, Hersey wants to save money for his first car. So he puts money in LeetCode Bank every day. So he starts by uh, putting $1 on a Monday, and then on every subsequent day he'll put a $1 extra of the previous day. So on Tuesday, he'll put $2. And then Wednesday 3, then 4, 5, 6, and 7 until Sunday. And after that, in the next week, on the Monday, he will put $1 more than the previous week's Monday. So that means he'll start with $2 and then he'll repeat the process. So plus one of each day. So 2, 3, 4, 6, 7, 8. So far he has put money for 2 weeks, and then the next week on Monday he'll put $1 more than the previous Monday. So it starts from 3, then 4, and so on. So you're given n, so the number of days he will put the money. You just have to return the total amount of money he will have in the bank at the end of the nth day. So if we take the example, we have n equal to 4. So first day, second day, third day, fourth day. So the total money will be 1 plus 2 plus 3 plus 4, which is 10. And for the second input, we have n equal to 10. So this is first 7 days, and then this is the next 3 days. So total 10 days. So here the sum will be, this sum is 7 into 8 by 2. This is 28 plus 3 plus 2 plus 3 plus 4 plus, 2 plus 3 plus 4. 7 days plus the remaining 3 days. 4, 5, 8, 9. So total we have 37. So at the end of 10 days, he'll have $37 in his account. And finally, we have the third input, n equal to 20. That means first week, second week, and in the third week, he'll put money for the remaining 6 days. 5, 6, 7, 8. So if we add all these numbers, you'll get the sum as 96. So for this input, the answer is 96. And in the constraints, you have n equal to, n is ranging from 1 to 1000. Now let's go with the approach. So to solve this, you can, since the n is very less, you can directly iterate from 1 to n and initially start from $1 and keep a track of week number and keep a track of the current day. So this is week number 1. This is week number 2, week number 3. So you'll start from $1 and then you'll iterate a loop from 1 to n, and you'll keep increasing the value and keep adding it in your sum. And as soon as you iterate on the first 7 days, you reset the sum. You increase the week number by 1, and then you reset the sum value by 1 by the week number, and then you start iterating. So let me just quickly write the code for this. So this is not the approach we'll be discussing at the end. We'll solve this problem in order of 1 complexity. So just for reference, initially we'll just take answer equal to 0. Just remove this. Yeah, and then we'll start iterating from I equal to 1, I less than equal to n. We'll also keep track of days. Initially day equal to 1 and week equal to 1. And also initially you will have money equal to 1 as well. So on first day, answer plus equal to money, and you will increase the money by 1, so that on Tuesday you will add $2. You will repeat this process for the first 7 days, and you'll also increase days plus plus. And you don't need days because I only is denoting the days here, so I can just remove this. So after the first 7 days, that means if I mod 7 equal to 0, that means you have finished a week. So you'll increase the week, and then you will initialize the money variable by week. So money equal to week. So after the first 7 days, you are starting with 2, and you'll finish this week. After that, the week becomes 3, and then you'll start with 3, and so on. So this is a simulation for the first n days, and then at the end you'll just return answer. You just test it. Yeah, and I'll also submit. Yeah, this code works, but it's a bit slow since the time complexity for this is order of n. So we'll just see how we can optimize this code. So for that, I'll just I'll just do the simulation for a few days. So the first week we have 1, 2, 3, 4, 5, 6, 7. Then the second week we have 2, 3, 4, 5, 6, 7, 8. And then 3, 4, 5, 6, 7, 8, 9. Then 4, 5, 6, 7, 8. So suppose we want to calculate the answer for n equal to 26. That means we need to add the sum of all these numbers. So let's see, let's try to derive a formula so that it will work for any value of n. So we have n equal to 26. So if we do 26 divided by 7, we'll get the quotient as 3. And when we do 26 mod 7, we'll get the remainder as 5. That means 3 indicates we have 3 full weeks, and then the remainder indicates in the last week we only have 5 days. So now let's see, let's concentrate on the full weeks. So in the first week, your sum is sum of first 7 natural numbers. So that means sum of 1 through 7. That is the sum of the first week. Now for the second week, it is again same. But to this, you will add a plus 7. Because if you see, every number is a plus 1 of the previous number. So if you subtract this value from this value, you will get the answer as 7. You can just think it as from this number, remove a 1. So this will become 1, this will become 2, this will become 3, 4, 5, 6, 7. When you remove 1 from each number. So that 1 from each number is contributing 7. And the remaining value is sum of first 7 natural numbers. So this is the sum for the second row. Let me just write it here only. Now for the third week, it is similar, but you will remove 2 from the first day, you'll remove 2 from the second day, 3 from the third day. Sorry, you remove 2 from every day. 2 from this, 2 from this, 2 from this, 2 from this. So when you remove 2 from every day, your sum will become something like this. That means your sum is 1 through 7. And since you removed 2 from each day, you'll just need to add 2 times 7. So this is the sum for the third week. So to generalize this, for the week number X, your sum will be 1 through 7, sum from 1 to 7, plus x minus 1 into 7. So this is the sum for the week number x. Now you just need to add all of them. So that means first you need to add sum from 1 to 7, and you have this the week number of times. So you have 3 weeks here. So 1 through 7 into 3. So this will give you the sum of all this part. And you need to add this part as well. So for this part, it is something like 7 into 1 plus 7 into 2. But for week 3, you have until 2. If you have week number x, you will have this until 7 into x minus 1. That means for week number x, the sum will be like we discussed here. The sum is 1 through 7 plus x minus 1 into 7. So when you add all of them, it is something like 7 is common. So 1 plus 2 plus 3 up to x minus 1. That means 7 into sum from 1 to x minus 1. So this will give you the sum of the full weeks. After that, you need to add the sum of the half week separately. So in this example, this is week number 4 and we have only 5 numbers. So since we only have 5 numbers, we'll just take sum of first 5 natural numbers. So that means 1 through 5. And this number is formed by when we subtract 3 from all of these numbers, this will be 1, this will be 2, this will be 3, this will be 4, and this will be 5. When you subtract 3 from each of this number. And since you subtracted 3 from each of this number, you'll just add the 3 back. That means plus 3 into the number of numbers in this week, 5. So this 3 is the quotient, and this 5 is the remainder. And this 1 through 5 is the sum of first 5 natural numbers. So for any given value of n, first we calculate the quotient and the remainder, and using this formula, we can just fill the values. Now let's quickly code the approach. So let me just duplicate this function. And first we need to calculate two things. Int division value is n by 7. And you have the remainder is n mod 7. And your answer will be, first we'll look at this part. So sum of first 7 natural numbers, you can get it by doing n into n plus 1 by 2. That's the sum of first n natural numbers formula. So you can have 7 into 8 by 2. This will give you the sum of 1 through 7. And this value you will multiply with the number of weeks, which is number of full weeks, which is the div. And to this, you will write 7 into. Here you have sum of first x minus 1 natural numbers. That means x minus 1 into x minus 1 plus 1 by 2. So this is same as x minus 1 into x by 2. So this value, and here x is the week number, which is 3. We have 3 full weeks. So here we can write div into div -1 by 2. Here it's not x. Let me just properly. It's div -1. So far in your answer, you have computed for the full weeks. Now you have a week which is extra. So for that, in my answer, I'll just add sum of first 5 natural numbers. So for that, again, we can say remainder into remainder plus 1 by 2. And to this, you will add 3 times 5, which is div times remainder. Div into remainder. And at the end, just return answer. Let me just comment this. Okay, wrong answer. So div is n by 7, remainder is n mod 7. So I think the issue is we are dividing before multiplying the whole thing. So we will lose the decimal points. So first we have to multiply the whole thing so that this term will become even, and then we have to divide it. Oh, and here we have to add this term and not multiply it. Okay, let me submit. Yeah, and it works. And you can see that the time is also 0 milliseconds. So this approach is faster than the previous approach. Finally, let's do the time and space complexity analysis. So here for time complexity, we have order of 1. Since we are not running any loops, we are just doing a few divisions and multiplications. And similarly, space complexity will also be order of 1. Since we are just using 3 variables. I also have the code in Python if anyone wants to view it. I'll add it in the description as well. And let's catch up in the next video.